Hello and welcome to tribetopper.com.
You're watching this video on important concepts of current electricity. In this video, we are going to talk about drift velocity. Now, what is drift velocity? See, when electrons in a conductor, as soon as the conductor is connected to a battery, all the electrons, they experience a force towards the positive terminal. And this force is because of this electric field set up inside the conductor. Because see, as the conductor is connected to a positive and a negative terminal, there is an electric field, we would say, applied to this conductor, and that is equal to V upon L, the potential difference applied per unit length. And because of this electric field, the electrons experience a force. So that force F is equal to, we know that the force due to an electric field is Q times E, but Q here is the electronic charge, so it's minus E times E, because the direction of force is opposite to the direction of field, because force is acting towards left, whereas the electric field is directed towards right, because it goes from positive to negative charge. Now, when this force is applied, and if we say m be the mass of this each electron, right, m be the mass of an electron, then in that case, what would be the acceleration of this every electron? It will be force upon mass. So the acceleration is equal to this force minus E times E upon m. Now that's the acceleration we have. So in this conductor, your electrons are flowing from right to left, but your electric field is applied from left to right, and due to the force which is acting because of this electric field, it causes the electrons to accelerate, given by this equation number 1. Now, under this acceleration, a huge number of electrons are flowing. When all these electrons flowing, they are in direction, they will collide with each other, they will keep colliding with each other, and also with the walls of the conductor. Every time they collide, they would stop. Then again, because of the force acting on them, they would start moving, but then they will again collide. So we need to know here that there is a certain time gap between two successive collisions, and we call that time gap as relaxation time. So the relaxation time, we can define it as relaxation time, as the name suggests, the time for the electrons to relax. So relaxation time is the time interval between two successive collisions, right? Time interval between two collisions or two successive collisions. So once an electron collides, then stops and then starts moving again, and before it collides the next electron, the time interval during that is called relaxation time, and we denote it by tau. So now, using all these parameters, let's find out what will be the average velocity with which the free electrons in a conductor are moving, or rather they are drifting, and that is why the term drift velocity came into existence, because the electrons are actually not moving very fast. They are moving, but they are colliding also. So the net effect is that the electrons are just drifting like this, but it's a huge number of electrons drifting. So the current appears to be moving very fast through any conductor when you turn on an appliance, but actually the electrons are drifting. So let's find out what is the relaxation time, what is its role in finding this average velocity. Now we have already done the equations of motion, right? So what should be the velocity after the first relaxation time? So we are talking about one electron, so V1, its velocity would be u1 with what it started initially, but it has gained an acceleration a in the time tau 1, right? Similarly, after some time, the next relaxation time, this will be the velocity of the other electrons. So we would go and keep this up to Vn. So what is going to be the average velocity? That gives us the drift velocity. Therefore, we can say the drift velocity, we would define it as, hence we can define the average velocity with which electrons get drifted under the influence of an external electric field. So when under the influence of an external electric field, the electrons drift, they have an average velocity, and that average velocity is called the drift velocity. So how can we find out the average drift velocity? See, we know the average is always the sum of the observations over the number of observations. So we have an average drift velocity as V1, we'll put a vector sign here, it's V1 plus V2 plus so on up to Vn, because we have n electrons flowing, and this upon n, and just substitute all the values of V1, V2 like this here. So we would have, so we get drift velocity. If we substitute the values of each V1, V2, V3, we get U1 plus U2 plus so on up to Un upon n plus A times tau 1 plus tau 2 plus so on up to tau n by n. A would be common because we have the same acceleration for all the electrons, and this term would be termed as the average relaxation time. And because the initial velocities of all of them, this average would turn out to be 0 every time. Therefore, considering U1 plus U2 plus so on up to Un upon n as 0, we would get the drift velocity to be equal to A times tau. Tau is the average relaxation time, and therefore in turn we get Vd, the drift velocity, is equal to, if we substitute the value of acceleration, which was force by mass, so it's minus E upon m times tau. Now this is the expression that we have derived for the drift velocity. It's a very important 3 marks question for your board exam. I hope you've understood how to derive the relation for drift velocity, which is not very difficult. We just applied the electric field, found out the force acting due to the electric field and the acceleration, and just apply the formula of average velocity, where we have substituted the individual velocities to be from the equations of motion as u plus at, where u would be u1 and t would be tau, the relaxation time within which every electron accelerates, and just take the average. Then it's just simple mathematical rearrangement of the terms, and you derive the expression for drift velocity.
Please follow us on Instagram, Facebook and Twitter at tribetopper.com.